Okay, guys. How many of you declared your variable as x? And that if x is the number, then the other unknown is the reciprocal. Well, it's easy to get the reciprocal of a number, just 1 over it, right? So therefore, if you add them together, it equals to 13 over 6. You then multiply both sides by the LCD. Now, before I do, I should figure out that, oh, I cannot use 0 as my answer, right? So I wrote down my restriction and multiply both sides by the LCD, which is 6x. Okay. I'm sure a lot of you have already done this, right? Now that I gave you time. So what does this become then? Yes, sir.
It becomes 6x squared.
Yes.
Plus.
Yes.
6
Mm-hmm.
is equal to 13x.
Yes, very good. If I have an equation that looks like this is not linear, therefore we have to use zero product property. So we have to make it equal to 0. So subtract 13 from both sides, and we get a 6x. We get 6x squared minus 13x plus 6 equals to 0. Marilyn, how do we factor this? Question. Linear is okay. If it's linear, you only have x to the first power. Any equation with x to anything else. Okay. That's a short answer. Anyway, so then what do we do? Yeah, how do we factor this? 3x. Okay, I want you to then go. Everybody do it. See how do you factor. Everybody factor this now. Give you some time. So a lot of you should have gotten. When you factor that, remember I told you to use 2x and 3x first instead of using 6x and x first. So when you do that, you get 2x and 3x, and then negative 3 and negative 2. It works out this way. So it factors as 2x minus 3 times 3x minus 2. This is only true if each of these factors are 0. So when I put them equal to 0, this is true if 2x minus 3 equals 0 or 3x minus 3 equals 0. You get two solutions, 2/3 and 3 over 2. And could I write my answer right now? I found two answers. None of them are restrictions, okay? Unlike your homework from last time, right? Your homework, there were a whole bunch of restrictions, remember? So a lot of you got no solutions. Anyway, am I ready to write the answer? No, you must check. You must check because every time you multiply both sides by a negative number, variable, you must check because you may be introducing new solutions. So when I checked, by the way, how come I only checked one of them? Why didn't I check 2/3? Shouldn't I check 2/3 too? I only checked 3 over 2. In this case, it doesn't really matter because, Kobe.
They're the same.
What do you mean they're the same?
Because if you do 3 over 2, then the reciprocals, but if
Exactly.
you do
So you'll be adding the same number. So, yeah, but normally you gotta check all these solutions. This one, there's no need because 3 over 2 plus 2/3 is the same as 2/3 plus 3 over 2. And it does work out, so here's your answer. The numbers are 3 over 2 or 2/3. It makes sense that the other answer is reciprocal of the other, right? That's what you're adding anyway, right? So, there you go. It works nicely. Now, I want to go to example 3 and come back to example 2 because of time. So let's go to example 3 now. Now, example 3, we need to fix something. Hold on a second. Go to example 3 now. Okay, so can you guys please write positive? So the positive numerator of a fraction is, because it'll be more clear, I think, if we do it this way. So write this down. Can you please include positive numerator of a fraction is 1 less than the denominator? Okay, please do that. And let's do this one together because this one is very interesting. The numerator and the denominator are both increased by 4. The new fraction will be 1/8 more than the original fraction. Okay?
I missed all my
Okay. Alright. So can you tell me what the unknowns are for this? Let's do this one together because it's important to kind of start off together correctly. What's our unknown? Tony, what is our unknown? X the numerator and x plus 1 as the denominator. That's what I would do. Very good. Guys, could we have done it the other way where I declare x as the denominator?
No.
Yes, you can.
Oh,
Then the numerator will be x minus 1. But do I like subtraction?
of course not.
No. So we declare the variable for the smaller value, right? The numerator is 1 less than the denominator. Therefore, I let x to be the numerator and x plus 1 to be the denominator. You could do it the other way, but let's just start off this way so that we'll be on the same place, you know? Because other people did it as, you know, x minus 1 and so forth. And we don't get the same equation, okay? And people are asking me questions. So let's just do it this way so that we're all on the same place. Now, who could tell me the original fraction? What does my original fraction look like if we declare our numerator and denominator this way? Laura? That's right. It's x over x plus 1, right? That's where you have the numerator less than 1 less than denominator. Now, okay, then, all right. What do they mean by? So look, it says if the numerator and the denominators are both increased by 4. Does this mean this? Watch this. Does it mean this? No, big hint. It says there's a big X. Okay, it does not. I mean, what does it mean when they? Okay, raise your hand. 1, 2, 3, 4, 5. Aaron.
It's like x plus 4 over x plus 1 plus 4.
Exactly right. So you're just basically just adding, right? 4 to the numerator, 4 to the denominator. Now they're saying if you do this, it says the new fraction will be 1/8 more than. So does it equal to 1/8? No. Okay, so people just read it up to here and just write 1/8. That's not correct. It says 1/8 more than the original fraction. We just talked about what the original fraction looked like. Who could tell me what this whole thing equals to then? Remember, it's just more than, so you gotta add the number later. So let's see. 1, 2, 3. Anais.
Is it x over x plus 1 plus 1/8?
You're perfect. That's perfectly right. So the original fraction, which is x over x plus 1, plus 1/8. Anais got it perfectly right. Isn't that right, guys? This was now.
Nice job on you.
Good job. Now we need to. Yeah, question. Okay, we got a question. Why do we put 1/8? Okay, ask your group now. Right? It's just 1/8 more than the original. Okay, now, guys, listen. Is it okay to figure out our LCD at this point, or Shirag, remember what I said? Okay. Or is it? Should we do something before we figure out our LCD? Factor? There's nothing to factor.
Always simplify.
Thank you. Always simplify. What do I mean by this? Yes, sir. Yes. Class? Do we know what x plus 1 plus 4 is? It is x plus 5. Now, it's easier to look at the LCD. Isn't that right? What's our LCD? So, guys, listen. You should always simplify, even, right? Because if you're looking for the LCD, if you leave it as x plus 1 plus 4, it kind of looks, you know, kind of hard. But it's really nothing more than x plus 5, isn't it? So what's our LCD on this? One person? Two? Matthew, what's our LCD?
8 times x plus 5.
Not quite. What about this x plus 1 on the denominator? You forgot about that one. There are 3 denominators that are different. Uh-huh.
X plus 5 times x plus 1.
Very good. What are our restrictions? LCD is nothing more than the product of all the 3 denominators. Of course, you're going to multiply both sides by the LCD, right? Okay. So, and what are our restrictions for this? How many restrictions do we have for this class?
A lot.
Lara? 2. No, just 2. What are they, Laura? That's right. So we want to make sure our answer doesn't come out to be one of those, right? So you don't even have to check. Go ahead, everybody then multiply both sides by the LCD right here, which is, and I'm going to give you time. Now, don't forget to distribute this, okay? Go ahead, everybody try. Let's continue on. I know that some of you are still working on this. That's okay. But I would like you to stop for now and watch I'll give you more time to finish it up. Okay? Okay, Kobe?
I'll make a little project.
Right. But can you wait? Let me, yeah. Okay, here we go. Here we go, guys. Class? I'll be doing the same problem. Okay, so as you look at this, it'll be what you need. Okay, so when I multiply both sides by the LCD, the left side, the x plus 5 cancel out. On the right side, you gotta distribute this, so you get x plus 1 cancel out with x plus 1, 8 cancel out with x. So you simply get 8 times x plus 1 times x plus 4 on the left equals to 8 times x plus 5 plus x plus 1 times x plus 5. Any questions so far? Then, of course, we gotta simplify this whole thing. So it's not too bad when you multiply them out. I'm going to multiply the binomial times binomial first. So it's easier for me to multiply. 8 times x squared plus 5x plus 4 equals to 8x times x plus 5. And then, of course, you get x squared plus 6x plus 5.
Ooh, I got that.
Okay. And when you gather all your like terms, you should have gotten this. Okay. So make sure you get this. I'll give you time now. Okay. This is what you need to get. A lot of you, right, this whole LCD, you have to distribute to each of these terms. There are 2 terms, right? You got to distribute this. So when you do, you get this. And of course, when you factor, you get x plus 9 times x minus 3. Because if you think about this, this is easy because the leading coefficient is 1. So you're asking yourself, what 2 numbers can you multiply to get negative 27? And when you add, you get positive 6, which is 9 and negative 3. If this is true, what are your solutions? Matthew? That's correct. There are 2 possible solutions, x equals to negative 9 or x equals to 3. At this point, I can drop x equals to negative 9. Does anybody know why? Yes, Kristen. Yeah, because it's the positive numerator. So here we could just drop this. Okay. Because we're looking for positive numerator, okay? So I don't even have to do the check here. Don't need that. Okay. And when I plug in 3, it does come out to be true, right? You get 3 over 4 plus, you add 4 to top and bottom. It does equal to 3/4 plus 1/8, right? So what's your solution? Yes? How do I get 3/4? That's a very good question. How do I get 3/4, guys? Yes? Yeah, added 1. Remember, our original fraction was x over x plus 1. Remember? So that's how we knew was if my numerator is 3, you automatically know your denominator. It's 1 more than the numerator. So, therefore, the original fraction is 3/4. Any question? Let me erase this whole thing. I don't know why I even bother checking, because I know that my denominator can't be negative. So, numerator has to be positive. Right? You cannot use x equals to negative 9. Any question? Aaron? Aaron, any question? All right. So then let's go to example 4. So example 4 is actually first time we're going to be actually using 2 variables for the first time. Remember we told you during second semester we're going to go from using 1 variable to using 2 variables. So this one is one of those. Okay, so let me show you how to do this one. Jenny commutes 30 miles to her job each day. She finds that if she drives 10 miles per hour faster, it takes her 6 minutes less to go to work, to get to work. Find her new speed. What are our unknowns? Yes.
Her original speed?
Her original speed and something else. Yes.
Her new speed?
Her new speed, yes. Anything else, Talene? The time that takes her usually to get to work, and also the time it takes, the new time, I guess. Okay. Does that? What about distance? Do we know the distance?
No.
Yeah, 30 miles. We do know it. They told us.
30 minutes.
Oh, it says miles. Okay. So you're right. So let's declare this together. Let's declare the variable for the rate. I should have done r, but sorry, I did x. Let x be the regular speed. Then what's our new speed, class?
R plus 10.
No. It's yeah. No. You said it right, Kobe. Somebody said y. It's not y. It's x. No, well, I said x. So x plus 10 is the new speed, right? If x is our regular speed, then x plus 10 is our new speed. We don't declare another variable for that one because we could actually declare the variable right using the x. Then, but time we don't know. So let t be the regular time, right? That takes her to get to work. Then what's our new time? Raise your hand if you think you know. By the way, how many people think it's t minus 6?
No.
Why not? Isn't it less? It says 6 minutes less. Isn't it t minus 6? That will be wrong. Madeline? Is it 6 plus t? No. It says it takes her less time. If she is it 6 minus t? No.
T minus 6.
Talene.
Because it's going by miles per hour.
Thank you. It's going for miles per hour. We cannot use 6. That is not in hour. So, Talene, what should it be?
1/6. 1 over.
1/10.
It's not 1/6.
T minus 1/10.
1/10.
1/10. So do we add 1/10 to this t, the regular time, or do we subtract? Is it t minus 1/10 or is it 1/10 minus t? It's t minus 1/10. It's whatever the time it takes her is less than 6 minutes less. So be careful, guys. This is where people make mistake right here. They write something like t minus 6, or they do like 6 minus t. That's all wrong. It's t minus 1/10. Yes,
T minus 1 over 10.
that's what I have up here.
T
Huh?
minus 1.
Isn't that what I have? T minus 1 over 10. Yeah, look up. Isn't that what I have? Yeah, question?
I don't get why you subtracted 1.
Okay, hold on. Again, please, at this point, Alvin, okay, what's your question?
Like, does 1/10 equal 6 minutes?
Yeah. 1/10 is 6 minutes, right? 1/10 of an hour. If you don't believe me, multiply top and bottom by 6, right? It's 6 over 60,
Oh.
right? So, right, guys?
Yes.
Now, do you think we're gonna need to use the RTD chart for this one? Yes. Okay, go ahead and fill out this RTD chart. Yeah, rate times time equals distance. You guys already forgot that? Okay, so there's a regular, right? The regular way she drives, and then if she goes the new way, right? Where she goes faster. Go ahead, everybody fill it out and see what you get. Okay. Give you some time. So who could tell me the rate for the regular? Yes, sir. X. What's the rate for the new? Yes. John? X plus 10. What is the time for the regular? Raise your hand. Judy? T. Then what is the time for the new, Judy? T minus 1/10. What is our distance, Audrey? Oh, for the regular. What's the distance for the regular way of going to work? X times T. Yeah, that's true, but we actually know the numeric value for this, don't we? Yeah, what's the distance? 30. It's 30 for both. Alright? Yeah, so, yeah, you could write down X times T. We will use that to find then what? Right end? Equation, but, right? Isn't that what we get? We know the distance is 30 because that's what it says in the very beginning, right? Jenny commutes 30 miles to her job each day. Right? So we have used two variables, have we not? How many equations do you guys think you would need to solve an equation with two variables? If I had 3 variables, well not on this one, how many equations would you need?
3.
If I had 10 equations, no, 10 variables, if I had 10 variables, you would need? 10. No, you need 10. Okay, so, what is the first equation that we get from this? Raise your hand if you think you know. Because we need 2 equations because we use 2 variables. That's what we get for using 2 variables. We just need 2 equations. Yes, sir.
X times 10 is 30.
X times 10? Where do you get X times 10?
Where'd you get 10, Andrew?
Where do you get 10, bro? Oh wait, X times T.
Yeah, X times T. Very good. Okay, X times T equals to 30. Shh. Okay, what's the other one? Owen?
X plus 10 times T minus 1/10.
That's right. So those are the 2 equations we get. Now, oops. Okay, do you see the two equation? X times t, rate times time equals the distance, and then another rate times time equals. Now, but we don't know how to solve these kind of equations. But if we do something, it's called substitution method. Watch this. If I can substitute, you see where the t is? It doesn't matter. I could have done for x. Doesn't matter. But if, so I'm gonna just choose t. Yeah. If I in place of that t, is there a way to rewrite this equation so that I could substitute a value for t so that the whole equation has only one variable? Because otherwise we don't know how to solve, right? Is there a way to do this? In other words, is there a way to rewrite? Is there a way to solve for t on this left side equation? What do we do here, guys? Divide both sides by x. Yeah, I should have done x. Yeah, that's fine. If you were okay, so then look what happens. Aren't they equivalent? If x times t equals to 30, isn't t equals to 30 over x? So guess what I'm going to do in place of this t then? I'm going to plug it in. This is called substitution method. Why do you think it's called substitution method? Because you substitute it in. And how many variables would you end up if you substitute that in there, in that one equation? You would have only one equation. Okay, so you get x plus 10 times, instead of t, we substitute in 30 over x minus 110 equals to 30. Are we okay? Is this the answer? No, we haven't solved yet. We're getting to the equation that we could solve now. By the way, guys, always simplify. So I don't like this left side. How do I simplify this? I don't like these parentheses. Yeah, tell me. Yeah, you could make it into one fraction on the right, okay? Or you could just multiply this out. Can't you not? Do we know how to multiply this? How do you multiply this? No. Look at the left side of this equation. It's binomial times binomial. Shouldn't we simplify by multiplying these two? Yeah, FOIL. You guys remember FOIL? Everybody go ahead and do FOIL. See what you get. Well, multiply it out. X times this times this. Don't you have to multiply it like this? Don't worry about it. It's just multiplying two binomials. Okay, you guys remember how to multiply two binomials? Go ahead, everybody try. Okay, here we go. Let me show you. So did you all get 30 minus x over 10 plus 300 over x minus 1 equals to 30? Okay. Now, what should we do to both sides, class? Yeah, you could simplify first, I guess. But I just multiply both sides by the LCD. Is that okay? So I guess it's better to simplify. Go ahead, everybody simplify and then see what you get. So did you all get, when you simplify, you should always simplify, right? Always simplify. So when you do this, listen. Oh, sorry. So you get here. I added 30 and negative 1. You get 29, and then I subtracted 29 from both sides. So you get negative x over 10 plus 300 over x equals to 1. Multiply both sides by the LCD, which is 10x. When I do this, I simply get negative x squared plus 3,000, right? The x's cancel out. Equals to 10x, right? Right? You got to multiply both sides by 10x. And we want to make it equal to 0 so that we could use zero product property. You should have all gotten 0 equals to x squared plus 10x minus 3,000. Oops, 3,000. Okay? Correct?
Nice job, Lindsay.
Do we know how to factor this trinomial? What? Listen. What? Okay, our leading coefficient is 1. Right? That's easy. How many ways are there to get x squared?
One way.
Yeah, x and x. So it's got to be x and x plus. What do we need for 3,000? Yes, Christine?
Okay, on the top
Yeah.
it's negative x plus 3,000, and after you subtract 10x, we got a positive 10x. And I know you did
Okay, so guys, when you factor this, listen. Okay, give me just a sec. When you factor this, you get 60 and negative 50. Hello? Guys, can it be negative 60? The answer is 50. Do they ask for the new speed? Okay, guys, give me a sec. Do they ask for the new speed or the old speed? So new speed is 60 miles per hour. Any question?